This is week 17, lesson 4. Okay, so these are starting to all sort of look the same to you, I'm assuming, right? When it, again, the directions are still the same, you know, solve the trig equation, here's the domain, okay? But where this might look slightly different is the fact that if I look at example 1, I have a couple different trig functions going on here, right? I've got sines over here, but over here I've got cosines. Also, the other difference is that not only that, but this is talking about angle X and this is talking about angle 2X. They're completely different angles. Okay, so you're going to have to make a substitution. So if you remember, oh, that's interesting. Get rid of that. If you remember, up here, and somewhere previous in your notes, you've got formulas so that you can make a double angle in terms of a completely different angle. Okay, now the question sort of arises, how do I know which of these 3 formulas I should use as a substitution? And the answer there is, I don't know. All right, so you might want it to be in terms of sine. In that case, use this one. You may want it to be in terms of cosine. In that case, use this one. Sorry about the bell. This particular problem that I'm working on has both sines and cosines, so I'm going to use this one, okay? I'm going to make a substitution. So when I go back to this problem and I make a substitution right here, it will look like this. Sine squared of x plus, now here's where I'm changing that cosine 2x into cosine squared x minus sine squared x minus cosine x equals 0. Okay, the only thing that I have changed, it's underlined in the original, it's now become this that's underlined in my new equation. Okay, now when I combine some like terms, you'll see that this sine squared x and this negative sine squared x, those cancel out. All right, so now my equation looks like this. Cosine squared x minus cosine x equals 0. All right, and now we're going to solve this by factoring, right? The same way you did in lesson 3. So I'm going to factor out a cosine x out of these 2 terms. I will be left with a cosine x and a minus 1. I'm going to set each of these equal to 0. Cosine x equals 0. Cosine x minus 1 equals 0, which gives me a couple different things I need to look for on my unit circle in one rotation. All right, so the cosine equals 0 up at the top at pi over 2 and way down at the bottom at 3 pi over 2. And the cosine equals 1 at the far right-hand side, which in this case we're going to call 2 pi because the 2 pi is included and the 0 is not. Okay, next, on this next example, okay, and again, notice it's kind of weird because on this side I have things in terms of sine, but on this side I have things in terms of cosine. It's really hard to solve an equation this way, so I'm going to go back to some formulas, namely this one, okay, and I'm going to manipulate it a little bit, okay. I'm going to take this equation and I'm going to rewrite it in terms of cosine. In other words, I'm going to move this to the other side. I'm going to have cosine squared of theta equal to 1 minus sine squared of theta. So I'm going to make this substitution in my equation. So let me go back to my equation. And I'm going to substitute it right here. So this is what I've got. Sine squared x minus 1 equals, and when I make that substitution, 1 minus sine squared of x. Okay, so now to solve this, I'm going to make it equal 0. I'm going to move everything over to this side, which is going to give me 2 sine squared of x minus 2 equals 0. Let's see, I think I'll factor out a 2 out of that. Sine squared x minus 1. And then I'm going to solve anything that has a variable in it. I'm going to set it equal to 0. So sine squared of x minus 1 equals 0. Sine squared of x equals 1. Take the square root of both sides. The sine of x equals plus or minus 1. And again, if I'm thinking about my unit circle, that happens here and here. So I have two answers, pi over 2 and 3 pi over 2.